Good morning, students. Welcome to CMD lectures. In the last class, we've seen the introduction of threads or threaded fasteners. Okay, we'll see the few more terminologies and how to represent the threads and what are the kinds of the threads. Okay. Okay, in the last class, you have studied all these things. So introduction, we have seen all these things. What are the permanent, or all these things? What is riveting, and all these things. What are temporary? In the temporary, we are having all these bolts, studs, and screws. Okay. Okay. What are the applications? Applications to hold the parts and to move the parts related to the other. So third terminology is very important. We discussed. Okay, external thread, internal thread, right hand thread, left hand thread we discussed. Okay, so this is the external thread. What is crest? The crest is the uppermost or the topmost peak edge of the thread. Okay, so root is the bottom of the thread cut into cylindrical bodies. Okay. Okay, you can see over here the thread angle. Okay, the thread angle is very different for different things. So this angle is given thread angle made by these two waves. Okay, okay. So this is angle called as thread angle. It differ from two edges of the threads. Okay, included angle between the two edges. Okay, or the helical cuts. Okay, thread angle. Okay, so it is different for different things, different threadings. Okay, we discussed root. Okay, thread angle is between the faces. Okay, you can see over here. Thread angle is okay, the angle between the threads faces. Okay, you can see over here. Okay. So we discussed the crest. This is the crest. Okay. This is the root. Okay, and this is the angle. In case of internal thread, it is a root, it is a crest. Okay, okay. So and this is a thread and angles. Okay. So major diameter. What is major diameter? So major diameter is the largest diameter seen on the internal or external thread. Okay. So major means largest. Okay. So larger diameter on internal or external threads. Okay. So major. Okay, so this is the major diameter from here to here they are shown. So this is a major dia. Okay. In internal also they have shown the major dia. Okay. So next. So minor diameter. Minor diameter is the smallest diameter on internal or external thread. Okay. So here it is there. You can see on the things a figure. Okay. So this diameter is the central axis. Okay. Okay. You can see over here. So this is the minor diameter for external thread. It is the smallest diameter. So minor. Okay. Minor means small. Okay. So here also you can see over here minor diameter. Okay. So major diameter and minor diameter we studied about. Okay. It is also called as a core. Okay. The major diameter is also called as outside diameter. Okay. Next. Pitch and lead. Okay. So what is pitch? Okay. So pitch means, okay. So pitch, the distance between the crests of the threads. Okay. You already know what is crest. Here from this point to this point. Okay. So this is called as one pitch. Okay, this is called as pitch. Okay, getting this point. So here also it is there. Pitch to pitch or root to root. Okay, so they are called as a pitch. Okay, so next, what is lead? Okay, lead is the distance a screw will advance. A screw will advance when turned of 360-degree. Okay, complete rotation. When you hold the things, a distance traveled, a screw will advance. Okay, of when you turn it of 360-degree. Okay. That distance will be called as the lead. Okay, that distance will be called as a lead. Okay. So there are various thread forms are there. Okay. So very important. Here the thread angle will be varies with the various forms, profiles of the shapes. Okay. We are having ISO is there, buttress thread is there, square thread is there, Acme thread is there, Whitworth thread is there, or English thread is there, national thread or unified. Okay, external thread is there. Okay, American nationals. Okay. So there are various different kinds of threads are there. Other thread forms are there. Okay. So knuckle threaded forms. Okay, we can see over here. So example for this. Okay. So these are the some examples. American national threads. National threads, unified, English Whitworth thread, sharp thread, sharp V thread, square thread, Acme thread, knuckle thread. You can see it on the this bulbs. Next is the buttress. Okay, so these are the kinds of the thread forms. Okay, so there we'll be having, for example, this isometric thread or unified thread. This one is isometric. So we'll take it this side. ISO, isometric. Isometric thread. Okay, the angle is here, it is 60°. Thread angle is 60° over here. Okay, so all these things are going to be given to you, all the 10 things. And even for the British Whitworth thread, here it is the pitch angle is 55°. Okay, British Whitworth thread. Okay, so here it is, angle is of 55°. Okay, next we will be seeing the various things. This is the square thread. Okay, so depth is of from here to here we'll have this. The depth is of 0.5 p. 0.5 p. P is nothing but a pitch from here to here. Okay, so anyway, that can be taken out. Next is Acme thread. Acme thread, the thread angle is 29°. 29°. And Sellers thread. Okay. Sellers thread is there. Next is the buttress thread. Buttress thread, here this angle is 45°. Or it is also included angle is of 60°. Sellers or sharp V, 60°. Okay, so these are the forms of threaded forms of the threaded forms. Okay, different kinds of threaded forms. Okay. External thread cuttings. How the external thread cutting has been done? Threading dies. Okay, threading dies. Next, okay, we'll be having these things. The dies will have the teeth, okay, thread forms or the profiles. With these things, we are going to make the external threads. Die stocks. Okay. So operations like this. Internal threadings, how the internal threadings are being done with help of twist drill, tap, wrench. Okay, so tapping tools are being used to draw the internal threads. For examples, in the nuts. Okay, nuts are going to made with help of tapping tools. With the help of tapping tools, we are going to create the internal threads. Okay, so this is the operation where it going to be happen. Okay, so here they have placed the object and they have used the tapping wrench. So this is this instrument. Okay, tapping wrench has been used. Okay, he has been using here also. Okay, it is being rotated. Okay, so with help of this tapping tool, so here it is. Tapping tool is there. Tapping tool. Okay, so with this help, we are going to make a external threads. Comparison of thread cuttings, external and internal. Measure dia. So how it is going to cut it? So it is also done in a lathe machines, lathe process or the thread cutting processes, even with the dies. For internal cuttings, so this is measure dia. So minor dia it is there. Okay. How to draw the thread drawings? So very important. So there are three kinds of thread representation.